chapter 21 video where we're going to be comparing two proportions. In this chapter, we're going to extend our knowledge of one proportion z tests and one proportion z intervals to comparing two proportions. So far, all of our examples have involved testing whether a single population proportion, p, equals some value, remember, which was our claim, and we called it p0. Now we're going to turn our attention for a bit towards whether one population proportion, we'll call it p1, equals the second population proportion, p2. The subscripts, the 1 and the 2, just differentiate the two different populations. Additionally, most of our examples thus far have involved left-tailed tests, in which the alternative hypothesis involved p being less than p0, or right-tailed tests, in which the alternative hypothesis involved p being greater than p0. Here we're going to consider an example that tests the equality of two proportions against the alternative that they are not equal. So that we're going to have a two-tailed test. Using statistical notation, what we're really going to test is for our null that the population parameter from population 1 is equal to the population parameter in population 2. Another way of writing that is that p1 minus p2 equals 0. Okay, and that's just saying there is no difference between the proportions of both populations, because that's what the null would say. The alternative, on the other hand, is going to have a variety of either not equals here. So it's going to be p1 doesn't equal p2. So we're saying that the population proportion from population 1 does not equal the proportion in population 2. And of course, another way that you can write that is we could also have p1 minus p2 does not equal 0. So that means that there is a difference between the two proportions. Fortunately, proportions observed in independent random samples are independent. We just need to use careful notation to keep these things straight. Okay, so again, that's where we emphasize using subscripts. You don't have to use 1 and 2. You know, if you're talking about, for example, a group of smokers and a group of non-smokers, you could use S for smokers and N for non-smokers. So since we don't know the true values of both populations, we rarely will, we're going to use sample proportions from the data collected to estimate the variances. So therefore, we are finding the standard error. And we've talked about this before, right? Here the formula changes a little bit. So the standard error, or SE, for the difference of sample proportions is notated like this. So the standard error of P1 minus P2. And I'm going to put hats over them since I don't know the actual population proportion. And if you think back to when we did one proportion z-test and z-intervals, we did p times q over n. Well, here, again, we don't know p, so we're going to have p, and this time we have two populations, so we're going to have p1 hat minus, or times q1 hat over n1, and n1 is your sample size for population 1, okay, plus p2 hat times q2 hat over n2, which is the sample size for population 2. And we're going to take the square root of that. Take a minute and pause the video to read the problem, and then we'll work this out together. The COVID-19 outbreak resulted in mass closures of businesses such as restaurants all across the United States. A Pew Research survey conducted in April 2020 asked whether respondents had ordered groceries online as a result of the coronavirus outbreak. 23% of 2,698 college-educated adult respondents answered affirmatively. Compare that to 19% of 969 adult respondents without a college education who responded affirmatively. What's the standard error of the difference in sample proportions? So first of all, I want to identify here the actual population. So P1 here, I'm just going to make that my sample proportion of college-educated adults okay, that ordered groceries online. And then p hat 2 is going to be the proportion of non-college educated adults who ordered online. Okay, so I need to look at the standard error of p hat 1 minus p hat 2. Okay, so what I'm going to do is I'm going to take p hat 1. So in this case, it says 23%. So that's my p hat 1. And I'm going to multiply that by q hat 1, which is 1 minus 23%, or 0.77. And then over the sample size for the college-educated adults, which would be 2698. Okay, plus I'm going to do the same thing for the non-college educated adults. So there it's 19%, so 0.19, and 1 minus 0.19 is 0.81. And then I'm going to divide that by the sample size of the non-college educated adults, and then take the square root. Be really careful typing that into your calculator. But when it's all said and done, you should end up with 0.015. Okay, so that's the standard error of the sample, the difference of the sample proportions for both of those samples. Okay, so as always, we need to check our assumptions and conditions, and of course, we need to check the independent groups assumption, which just says the two groups we're comparing must be independent of each other. Usually the independence of the groups from each other is evident from the way the data were collected. Okay, we want to check the randomization condition. So we're checking this for both groups. Okay, we're just saying that both samples were randomly chosen, or if it doesn't say random, remember, you just want to make sure that the sample that was chosen for both is representative of the population. The 10% condition says that your samples, so both samples must be less than 10% of the population, which they are. And then the success failure condition, there's going to be two parts to that. So remember in the past, you always wanted to do n times p has to be greater than or equal to 10, and n times q has to be greater than or equal to 10, but here we're going to have to do n times p hat 1, n times p hat q hat 1, make sure they're greater than or equal to 10. So you would have to do this and this. And then you also want to check it for group 2. So we should even put little ones there. So group 2 times p hat 2 and group 2 times q hat 2. Okay, so both have to hold for the normal model to apply. Okay, so that's the end of this video. In the next video, we're going to actually look at how to perform a hypothesis test. So we're going to apply what we learned in the past couple chapters to looking at comparing two proportions. So stay tuned.